So this is our video of how to configure the XNC drivers. First of all, you can see here that we have SET running. So what I'm going to do is I'm going to show you how to configure the XNC drivers. In particular, this one's a Modbus one. There is Mbus as well. We're going to start with the Modbus one. So I'll just walk you through how to find them, where to look, how to use them, and hopefully to give you a live demo as well. So first of all, we'll start with the normal way. We'll create a new SET project and we'll fill in the normal bits. We'll do something imaginative here. Okay, and what we're looking for is in our strategy library. Now this comes with all of the new installs of SET, and here what we're looking for is a standard solution. So here's our standard solutions, and in particular we've got XNC drivers. Now these ones you already knew about, and here's the ones for the IQ4. As I mentioned, we're going to be starting with the Modbus one. We've looked at the familiar ones, and we're going with a serial Modbus master. So you can just grab that solution and drag it onto this page here, and this is where we're going to start with our project. So we'll stay LAN 21 and we'll go for controller number 1. So at this point we always get asked if we should add some users to our strategy. For the sake of ease for me, I'm not going to add these users right now, but I will add them later. So you can see here in a normal way we have our LAN and our controller, and we're ready to go. So obviously we can change this at any point. It doesn't have to be called this. And already we have the strategy already. Now the point of all of these knobs and these sensors being configured already, I'll just show you what they look like, is that once we've configured the driver, we can delete the things that we don't need. So all of these things here, they're not needed necessarily. You could have all of them, have some of them, or just a few. So all I'm going to do on this one, just to get the ball rolling, is just show you how to configure 1 meter and say 10 records from that meter. At the end of this, hopefully we'll have a solution that you can just drag and drop and use at any time you like, and we'll get on with that now. So first of all, we can right click on a white space of the strategy and we can go to our interfaces, and in particular the XNC interface module. Now this is something you would normally get when you had TCL, and obviously we don't need TCL for this particular driver. All the TCL has been written already, so behind the scenes all the Modbus code has been written and we are now able to interface with a Modbus device. The tricky bit is setting up the comms, which is these fields here, and then also to configure a string. Now in order to do both of those things, unfortunately we need to read a datasheet, but I can get a datasheet up and I can show you where to look. So the things that we're looking for are the serial baud rate, the parity, the data size, and the serial stop bits, and also the serial port, which I'll explain in a minute. The datasheet itself I'll just get up now. So this is the one for the meter, which I have in front of me. On the first page it will just give you a little bit about what it is and what it can do. There's some menus there, and what we're after is here. So you can see that we've got a protocol here, the bus system, here's your transmission rates, bit settings, a little bit of technical information, and then there's the information that we need to do that is going to be found here. So the first part here is the RS485. So if we go back to our interface module, serial port. So if you type in 3, it's going to be RS232. If you type in 2, it's going to be 485. Obviously we need 485, so that value will be 2. The serial, okay, the transmission rate, here it says a transmission baud rate is automatically detected. So if we go back to our interface module, you can see that we have a baud rate here of 9K6, so we can leave that there, it doesn't need changing. Next one we'll look at is a serial parity. So we've got 8 data bits, even parity, and 1 stop bit. So 8, that's already there. Even parity, 1 stop bit. So we've got stop bit is 1, so that stays the same, and even parity, that should be 2. So that's it. So that's the comms set. These figures here, the timeouts and retries, they're all default settings, so they don't really need to be changed at this point. Now, these bits here, first request store number and the last request store number. So what we're going to do is configure one of these strings here, and these are all not used in this case. So it says here that the first requested store number is 16, which is here. So this is where we're going to write the string. You could have lots of strings there, and you could do, I don't know, another 10 down there, so it would be up to store 26, for example. So you would start at 16 and you would have your last request store number at 26. That means that this driver will efficiently go through each one of those strings rather than going through all 200 or up to 200. So for this bit of writing the string, we need to refer to the datasheet for the XNC driver. Now, the XNC driver datasheet is fairly long-winded. This is the datasheet. In an ideal world, it would be good if you read all of this. It will make sense and it will help you fault find. But for the sake of this demonstration, I'll show you where that string is that we need to configure. This is specifying a data request code, and this is what we're actually going to be writing in as a string. So, in the first place, this does look quite daunting. There's a description of what each one of these means. So for example, E and then the word device, what that actually means is it's a 3-digit number specifying the address of a device containing the required data. So I know that the address of my meter is address 40. So this first bit should read E040. So E040, and then it ends with a hash. And then we move on to the next part of the string. Function. Again, if we look at what the description is for that, it's a 2-digit code specifying the Modbus function used for the communications. That bit of information can be found on the datasheet for the meter. So you can see here the function, and these are the list of options that you have here. Now this information can be found again on the datasheet for the meter. So we're looking at function here. And here we are, data transmission. So it's read holding registers is 03, write multiple registers is 16. So at the moment I'm only looking at reading some registers. So I'm looking at 03. So this one here is F03 and then hash again to finish that particular part. The next part of the string is the address. Now this is the address of the register that you're looking at in particular. So for a meter, a good place to start will be the voltage, for example. Now again, the registers are all listed in the datasheet of the product that you're trying to interface with. Now again, in this case we're looking at this meter. If we scroll down on this datasheet, you'll see all the registers. Now this driver is not specific to this meter or any meter. It will work with any Modbus device. It's a universal Modbus driver, and it should work for anything that is Modbus. So here we have all the list of the registers. And here you can see that we have effective voltage of phase 1. So this is where I'm going to start. I'm going to start at register 36. So it needs a 5-digit number specifying the register address. So it's 36 is what I'm looking at, so the actual number will be 00036, followed by a hash to end that particular request. So what's next? Number of values. This is a 2-digit number specifying the number of values that you wish to read from that device. If I was interested in just the voltage, then I would ask for 1 request. But what I'll do is I'll ask for 10 requests. So it will ask for 36 all the way down to 46. So obviously that will be n 10 values followed by a hash. Next we're looking at the 0 or the output here. So that will be a 3-digit number specifying the first TCL output or input. Now these are going to be outputs, so I need to put that value on an output, and in this case it's going to be a sensor. So if we go back to set, we can see here that this is the output that I'm going to put that value on. So it will be output as in 0 and then 001. So the first one of those 10 values that I'm asking for will be displayed here, and then it will be put in order right down to output 10, followed by a hash. The error number, this is an optional thing which I don't need to ask for at this particular moment. Okay, so the C format I know is going to be, well, we just want a direct read from there, so it will be 00. So this part here with the format will be C00 followed by a hash. And then finally, the last bit here is the bit order. Again, this can be found from the datasheet, and it specifies the most significant bit or the least significant bit which to be displayed first. This is when you have 2 values for a register. So for example, I'll show you here on the datasheet again, where in some of the registers you have 2 registers that will represent a value. So for example here 4, 5, and down here 16 and 17. That's to display a larger value. For double registers, the higher register is sent first, so that's most significant bit first. So most significant bit first will be MS/LS. MS/LS. And that's it. That string's now configured. So as I mentioned up here, this will be where we start reading from and where we start end reading from. So there's only one store there, so I'm just going to put that at 16. And that should be it. So now if we press OK here, that's now, the strategy is now written. It's got lots of knobs and sensors there that we may or may not need. We can delete those later. The XNC interface has now been completed, so now we just need to download this strategy to a controller. So let's find a controller. It just so happens that there's one here. So what I want to do is download this strategy now to this controller. So it's given me a warning, reminded me that I need to put users in there. I will do that later. And when you first download this strategy, we need to make sure we include the XNC files, and then we download it. And now we see the strategy downloaded to the controller. So just to show you the how it looks, we'll go to live values. And here we can see the values that we're getting. We said 10 registers. So on this page we've got 9, and then obviously the 10th is here, and that's the only one that's reading on this particular page. So the good thing about this particular way of interfacing with Modbus devices, there's two things here. Let's just come out of live values. If we had another Modbus device here, and it's the same Modbus device, in this case a meter, we can edit this string here. So let's say that we change the address of that meter from, sorry, not from 40. Let's say that we add another meter here and we give it an address of 41. So we can copy that, we'll do Control C and Control V here. So we go back to start of this string. We've added another meter and we'll call it address 41. So we'll change the address 41. This function stays the same. These registers are the same because it's the same meter. I still want 10 values from there. But this time, rather than starting from output 1, which is from here, we'll go down from output 11. So we'll just change this from 1 to 11. And now it will record 10 registers from the other meter starting at output 11. All the rest of the data stays the same. So now that's written, we can just change this so it reads down to store 17 now rather than just stopping at 16. So we'll change this to 17, and that's it. And now I've added another meter and it will show the same registers on the next 10 outputs. So that's pretty easy. And the other thing that we can do here is that we can actually create our own solution here. So this is now with the sensors modified and deleted, the knobs that I don't want anymore. We can right click on here and we can do copy to solution. What this will do is this will save this project. So we have our IQ4E XNC strategy and we have it configured to talk to 2 meters. Now if you buy those same 2 meters every time and you address them the same way, then all you have to do is connect it up and download this strategy into it. You don't need to write the strategy again. You can put this in a group, and so now when we go into our strategy library, you can see that your custom solution will appear here, and you use it in the same ways. You can just drag that onto a page. In summary, we've used a Modbus XNC driver, we've configured it to talk to a meter, we've shown how to talk to more than 1 meter, and we've created a solution that we can use on any future projects that we have with those metering needs. And again, it's not just meters, it's any Modbus device that you can connect to. Thanks for listening. I hope this has been useful. If you need any further assistance, call tech support.